Welcome to classification of the system practical with the help of Matlab. First, we discuss outline of the presentation that include introduction, classification of system, linear and non-linear system, static and dynamic system, causal and non-causal system, time variant and time invariant system, stable and unstable system, invertible and non-invertible system. And then we discuss examples that to be solved using Matlab. First, introduction. So what is system? System is defined as set of elements or functional blocks which are connected together and produce an output in response to as input signal, where some of the nomenclature as x of t, that is t in parenthesis block parenthesis, that is represent continuous system, and x of n, that is in square bracket, indicate discrete system. For continuous system, x of t represent input system, y of t represent output system, x of t minus k represent delayed input system by k sample, where indicate past value. If k positive, the shift is to the right side. Then x of t plus k, advanced input system by k sample, indicate future values. If k positive, the shift is to the left side. Similarly, we have used nomenclature for discrete system like x of n, y of n, x of n minus k, and x of n plus k. Now let's discuss classification of system. First, linear and non-linear. So linear and non-linear system obeys the law of superposition, that include law of additivity and law of homogeneity. So that figure represent law of superposition with law of additivity and law of homogeneity, where x1t and x2t, both the system first represent or first gives output as y1t and y of t. Then we edit both the result, that in conclude y1t plus y2t. Second time, first we individually added the system x1t and x2t, then apply it to the system of y of t, and has produced the result y of t is equal to y1t plus y2t. So that is the law of additivity. When both the result, that is first result y1t plus y2t and second result y of t equal to y1t plus y2t, both the results are same, then we can say the system is linear. At the same time, we have to check the law of homogeneity. That means first x of t applied to any system represent y of t, and y of t applied to any constant k, that produce ky of t. In other case, x of t first applied to any constant k, kx of t generated, and after applied to any system that generate y dash t. So both the results are same, the system is said to be linear. So for the system said to be linear, it obeys the law of superposition. Then second is static and dynamic. Static system is also known as a memoryless system. Output depends only on present input, contains no energy storage in elements. Dynamic system with memory system, output depends on past and future input value, contain energy storage element. Third, causal and non-causal system. Causal system, that means output depend only on present and past input value, physically reliable system. Non-causal system, output depends on future input value also, physically not reliable system. Then next one is a time invariant and time variant system. Time invariant, that our input and output relationship does not vary with time, and time variant, input and output relationship does vary with time. So first figure represents the time variant system, where x of t applied to a system generate y of t delayed by t, y of t minus t. And second, first delay the input system by t sample, so x of t minus t system y dash t is equal to y of t minus 2. So when result y of t minus t in first case and second case both are same, the system is said to be time invariant system. That means input and output relationship does not vary with time. Second figure represent time variant system. In this case, first we applied system for x of t generate y of t delayed by t sample y of t minus t. Second case, first delay by input signal x of t, generate x of t minus t. In this case, after apply to the system and generate y of d, y dash t, and y of t does not equal to y dash t. That means system is vary with time. So this is a case of time variant system. Now next one is stable and unstable system. Stable system that obeys the condition of bounded input signal generate bounded output signal, that means BBO, and output does not diverge. An unstable system not satisfying the stable system condition, that means BIBO condition is not satisfied in the case of unstable system. Next one is the invertible and non-invertible system. So invertible system, one-to-one correspondence between its input and output, like this one, x of t or x of n applied to a system, generate y of t or y of n. If we inverse the system t inverse, in this case y dash t generate the same kind of input x of t, or y of n generate the similar kind of input of x of n. So one-to-one correspondence between input and output. In this case, invertible system and inverse system is possible. Next is a non-invertible system. In this case, one-to-many or many-to-one correspondence between its input and output. Now, after discussing all the 6 systems, that example to be solved using Matlab. So first, verify the given system is linear or not, that is y that is equal to 7x plus 0.5. Then second, verify the given system is static or not, that is y is equal to 7x minus k plus 0.5. Third, verify the given system is causal or not, that is y is equal to 7x plus 0.5. Then verify the given system time variant or not, that is y is equal to sin x. Then verify the given system is stable or not, that is for y is equal to 1 by x. And last is verify the given system is invertible or not, that is equal to y is equal to x square. So we have to verify the given system linear, static, causal, time variant, stable, invertible or not, that is with the help of Matlab. So let's do this kind of practical with the help of Matlab, and let's try to understand how we can solve the properties of system with the help of. So first is about checking linear system or not with the help of Matlab. So first let's use this command clear, that is the comment section. What is the indication of this line? That clear workspace. So any workspace is there, currently there is no value in the workspace, but if it is in there, then with the help of clear command we can clear that workspace. The next is a CLC. What is the indication of CLC? Clear command window. Then let's generate the function y that is equal to at the rate. Here we have used 7x, so here dot x, another bracket 7 multiplication of x plus 0.5. So that is the defined system for checking property, for checking properties. Then x equal to 0, so that define. Here we use semicolon, so it is not represent or not run in the command window, a semicolon used. Then command line defining x value. Then say x1 equal to input, say x1 equal to, and similarly for x2, because in linear system x1 x2 two system are there, so x1 is some value and x2 have some value. So this is the input value of x1 and this is the input value of x2. Then x3, that is the addition of x1 x2, so x3 equal to x1 plus x2. Okay, now here semicolon is used, so that particular line will not executed on command window. So that represent addition of both input. Now let's generate output system. So y1 that is equal to y of x1. So that indicates output value of x1 or output value for x1. Then similarly we have generate y2. So y2 y of x2 output value for x2. Then output addition, that let's say y dash or any variable. Here we have used m, so m equal to y of x3. So that indicate output addition of output. Now, or you can say addition for both added input, or addition for both added input. Okay, now let's check the condition. First, input is 0 or not, that we have to first check for linearity. So if y of x does not equal to 0, then condition to check linearity display system is linear. System is okay, not 0. So condition first checks the system is not linear. Here system is not 0 for any input. If input is 0, output should be 0 for linear system. But if input is 0, output is not 0, system is not linear. So this is the result display. Display result. Then second condition, else if, now second, if input, that means x3 that is equal to x1 plus x2, that is equal to y3. So y3 is equal to y1 plus y2. Okay, that I have to add y3 equal to y1 plus y2. So that is addition of output. So now I have to just check here. Now this represent addition for both added input. M is equal to y3 represent addition for input, and y3 indicate addition for output. Okay, so m equal to y3, that is addition of input, that is equal to addition of output. If it is yes, that is a condition. If it is yes, then display what is it? Yes, system is linear. So system is linear. Otherwise, so that is the display the result. As display system is non-linear. If addition of this one m, that is added input, that is equal to y of 3, adding of output or addition of output, the system is non-linear, and thus end this particular loop. So that is the first example to check whether the system is linear or not. After completion of this program, save the program, then run this program. So after clicking here run button, we have to wait. Now we have to check in the command window. So x1, so x1 is, let's say, 2. You can put any value, and x2 also put 2. So when x1 and x2 are 2, so in this case what happened, that means y equal to 7, x of 1 2, x of 2 2. In this case what happens, system is linear or not? System is non-linear. Why? Because of this 0.5 is there in the equation. If you remove this 0.5, let's check what happened. Save this program, run once again to this program, click on command window, once again same value 2 and 2. System is linear. Because of that constant 0.5, system represent non-linear. If you remove this 0.5, system is said to be linear. This is a workspace. Here you can see the different variable values am, x, x1, x2, x3, y, y1, y2, y3. Okay, so that is the way we can complete this particular program or to check linear system with the help of Matlab. Now second case is checking the static or dynamic system with the help of Matlab. So clear CLC same, I think same equation is there, but in this case one first I will just delete all this program, just run this program and you can see the result clear. So workspace is clear. Okay, so first clear CLC, if command window there is any there, okay, and command window some values is there. So when you click on CLC or run evaluate section, you can see the command window result is nothing or clear the command window. Okay, now just here I'll add some sample and input, enter n value. So that is the input for variable n, and then input k is required for whether check advance, delay or same. So k, that is the input, because we have to check present, past or future in static and dynamic, with memory or without memory. Enter k equal to, here I use semicolon, so that line is not executed in command window, and there is input variable for k, or input for variable k. Semi syntax रखते input for variable k. Next x equal to n minus k. Okay, so here I have used some kind of delay. So comment define x value that represent some kind of delay or advance or present. So and the function is y is equal to 7x plus same function tha 0.5. So define system second property. Now let's the condition, use the condition if n equal to k, that means check the condition for static, check the condition for static or dynamic. If n equal to k, that means display system is static. That means input is equal to output. So this is the display result. Else display system is dynamic. Display result and this loop. Okay, so this is the ending of loop. First save this, after that click on run button. Okay, now go to command window. Okay, enter value of n, let's say 6. So n equal to 6, k equal to 6. In this case what happens? 6 minus 6, x equal to 0. So that represents present or same value. So it gives a static result. Okay, so system is static. Okay, now let's once again run the system. So click on run, check on the command window. So let's say n equal to 6 and k equal to 3. Now what happens? 6 minus 3. So that means some value is stored, some value is there. So system is dynamic. So that is the program to check whether system is linear, dynamic or static with the help of Matlab. Once again I have to clear the workspace and command window with the help of this above 2 line. So now one workspace is clear as well as command window is clear. Okay, now repeat the program for causal and non-causal. Okay, so I think shifting is also requiring causal and non-causal. So input same, k is required, delay is required, similar kind of function is there, 7x.5 or 7p, any variable is required, any value is there, like 7p is there, 7x is there, 7x.5. Now condition is changed. So what is condition for causal and non-causal? For causal and non-causal, conditions like that: if x less than 0 or k less than 0, k less than 0, if both the values are less than 0. So check the condition for causal, non-causal, causal, non-causal. So the system is non-causal, both our values are less than 0. So non-causal and system is condition, system is causal. So let's check the result, how it is represent in the Matlab, or how it gives the value. So first run this program. So enter n. So first let's say n equal to 3 and k equal to, here n equal to 3 and k equal to 6. And so in this case what happened? 3 minus 6. So some minus of x is there in this particular function, because x equal to n minus k, some minus of function is there. So x of minus 3. So that represents future value, folded value. So future kind of result is there. So that's why the system represent, or systems gives non-causal results. So let's enter this. So system is non-causal. Now check with the reverse case. Once again run this program. So in this case first let's say n equal to 6, k equal to 3. So 6 minus 3, so positive value is there. So system is causal. So that is the coding for causal and non-causal system with the help of Matlab. I hope you enjoy this one. Now next one is about time variant and time invariant. So first clear workspace as well as command window. Okay. Now let's say CLC after. So in time variant and time invariant, we have to use some kind of variable that represent variable t0 that is equal to 1 and t that is equal to 10. So that is the initialization variable t0 and initialization variable t. Here I have just put semicolon, so this value is not there in the command window. So initialization variable capital T. So now first case, like case 1. So for case 1 we discuss that for t, small t, that is equal to 1 to capital T, for loop started. Now for x of t equal to 2 into pi into t divided by capital T. So there is the input for next sine function, and the y of t equal to sine x of t. So this is the output function. Now let's end this particular one. So first case we have just defined input and output with the help of for loop for sine t. Now second case is like case 2, that is for t equal to 1 to capital T, x of t equal to small t, input function, and y of t equal to t into x of t, that is output function. And end this loop. So now check the two. Here we have sorry. Here we have used two cases to check whether the system is time variant or time invariant. First, say input shift that is equal to sine x of t minus t naught, that is the input shifted by shifting by t naught amount. Then output shift that is equal to y of t minus capital T minus t naught. So that is output shifting by t naught amount. Now check the result. If input shift equal to output shift, okay, so that is a condition for time invariant or time variant. So input and output both are same, that means time is not reflected to the given system. So the system is time variant or time invariant? System is time invariant, because there is no effect of time variation, time invariant. Result is same. If not, then else system is, this is the displaying result. If not, that means else system is time variant. And now end this loop. So here we have used two cases. Let's check one by one. So here I have used comment for the second case, and first check for the first case, that is for x of t equal to 2 pi t by t and y of t is equal to sin x of t. Here just I have mentioned the semicolon so that the result is not there on the command menu. Save this one, now run this. So workspace, now command window. System is time invariant. That means system is not changed according to the input and output variation with time. Here the input and output shift is there because of there is no semicolon here. Okay, so you can see the direct result. The system is time invariant. Okay, now check for the second case. Now comment this line or comment this section and uncomment the second case. Now run this program. Here tx of t is there. First input is x of t equal to t and output y of t is equal to t into x of t. Then run this one and say the system is time variant. Why? Because of the multiplication with this t value at output side. So in this second case, output is changed or input output is affected due to time variation. So that is the time variance or time invariance can be checked with the help of Matlab. I hope you understand this program. Okay, now move to the next one, that is a stability. So first I have used these two lines to clear this workspace as well as command window. So now for stability, first I display okay, what is this program for? So program to check stability of the system, then that represent display, then next display enter input x, enter input x, display, then x equal to input say x equal to some value, so input x, and y equal to 1 divided by x, divided by x. So that is the output. Y, then z equal to absolute value. How we can check the stability? That bounded input, bounded output, or some magnitude, that is a finite. So that's why I have used absolute command. So absolute of output. So this is a condition calculation absolute value of y. Now condition to check stability: if this magnitude z is less than infinite, that means some finite value, that is a bounded output. So condition for stability, then display system is is stable. Display result. Else display system is unstable. Result. Now end this loop. So is the ending of loop. Save this program, run this program. Let's go to the window. Program to check the stability of the system. Enter value of x. So first I put value x as a 1. So here y is equal to 1 by 1. So y is equal to 1. Absolute of 1, that is a 1. So system is finite. Generate finite magnitude. The system is stable. The system is stable. Now run once again this program. Now check the value. Program to check stability of the system. Error. Enter input value of x. If I enter value of x as 0, so 1 by 0, that is the infinite. So z of infinite. So z is not less than infinite because it gives some infinite values. So when we put x equal to 0, system is generate unstable system. So that can be system stability can be checked with the help of Matlab, and I hope you understand this program as well. Now move to the last one of the classification of system, that is the invertible or non-invertible system. First use tool line, clear workspace as well as clear command window. Then generate function y that is equal to function of x. Then we have to check for the y is equal to x square. So x multiplication of value of x. Now that is a define the system to check linear invertibility. Define system check invertibility. Then next x equal to 0 initialization. Then x1 equal to input x1 equal to something. Then next x2 equal to input x2 equal to something value. So this x1 and x2 both represent input x1 and it represent input x2. Then generate y output. So y1 that is equal to y of x1. So that is output of x1 or output for x1. And similarly y2 that is equal to y of x2 output for x2. Now check the condition for invertibility. If both the result y1 equal to y2, 1-to-1 mapping or 1-to-1 correspondence for invertibility. So y1 equal to y2, then that is a condition to check invert system or not. Then display system is given system is not invertible because both are same, not like there is a y is equal to x square. So for phi we will generate 25, for minus phi also result is 25. So both the case output are same, input are different but output are same. So result is not 1-to-1 but many-to-1. That's why system is non-invertible. And this is a display result. Result as system is invertible. System is invertible. the result. Now end this loop, save this program, now run this program. So as I told you, first say x1 equal to 5, enter, and x2 is equal to minus 5, enter. So in this case what happens, for both the value output is same, so that's why given system is non-invertible. Thank you.